Hello everyone, so in this video we'll be discussing multiple integrals. This includes double and triple integrals. So basically, multiple integrals is an integral in which the integrand is integrated n times. So basically, this topic is, if we compare this with the differential calculus, this is similar with partial derivatives, wherein if you would integrate um, an integrand that is not the same as the notation of integration, you'll be taking that variable as a constant. So what do I mean with that one? So for example, we have here evaluation of definite double integral. So as you can see, we have two integrals here with two limits as well. We have from 0 to 1 and 0 to 4 x squared dy dx. So the first thing that we need to do in integrating this one is we have to integrate the inner part of our integrand. So we'll be integrating this one first. So we can rewrite that as 0 to 4 x squared dy. So what I meant earlier is that if you are integrating with respect to y and your integrand does not include any variable y, meaning to say you have to take this term as constant. Okay, so since this is constant, you can take that out, or you can put that out. You can write that as x squared from 0 to 4 dy. And then after that, you can already integrate the dy, in which the integral of dy is just equivalent to y. And then as we have the limits here from 0 to 4. And then you have to evaluate the limits by substituting the upper limits subtracted by the lower limits. So we have x squared of 4 minus 0. And as we know, 4 minus 0 is 4 multiplied by x squared. We have the 4x squared. But we are not yet done. This one, the result of the integral of this is 4x squared. So, meaning to say, this one now will be replaced by 4x squared. That being said, we'll be integrating this one again. So we have 0 to 1, what we have left here. And the dx, we have 4x squared dx. Okay? So after this, we'll be integrating this one again. So this is just the basic integration. Integral of 4x squared dx is, as we know, is equivalent to 4x cubed over 3. And then we have the limits from 0 to 1. Now, substituting the limits to our answer, we have 4 times 1 cubed over 3 minus 0. So that gives us 4 over 3. Okay, so this is now our final answer. Okay, next one we have integral or evaluate 0 to 3, 0 to x, y dy dx. Okay, again, the process is integrate the inner. So we have from 0 to x, y dy. So integral of y dy is just basically equivalent to y squared over 2. And then from 0 to x is our limit. So we'll be substituting 0 and x to our variable y. So we have x squared over 2 minus 0, or basically equivalent to x squared over 2. After that, we are already done with this one, which is now equivalent to x squared over 2. So meaning to say we have to integrate this one again from 0 to 3, x squared over 2 dx, where 1/2 here is constant, so we have 1/2 from 0 to 3 x squared dx. So integral of x squared dx, we have x cubed over 3, and the limits from 0 to 3. So we have 1/2 3 cubed over 3 minus 0. So this is now equivalent to 9/2 if you would calculate that. Okay, next example, we have evaluate 1 to 6 y over 2 to 3 of y dx dy. So isolating this one, our integrand, our equation is y dx. And since we are integrating in terms of x, meaning to say y is constant, so we can put that out. So we have y halves 3 dx. And as we know, the integral of dx is just equivalent to x. So we have x from y over 2 to 3. So we have y times 3 minus y over 2. Because again, upper limit substituted to x, subtracted by the lower limits, substituted to our x. And then, let's simplify this one before we integrate it again. So we have 3y minus y times y over 2 is y squared over 2. So this is now the simplified answer or value for our integrand here. So we'll be integrating it again using the outer limits and the outer notation of differentiation. So we have 1 to 6 of 3y minus y squared over 2. That is now with respect to dy. So we can just integrate this automatically. So we have 3y squared over 2 minus y cubed. And then we have 2 times 3 exponent. So we have 6. That is again from 1 to 6. So subtracting the upper limits by the lower limits, we have 3 times 6 squared over 2 minus 6 cubed over 6, subtracted by the lower limit, 3 times 1 squared over 2 minus 1 cubed over 6. So this would give us 18 minus 4 thirds, or basically equivalent to 50 over 3. So this is now our final answer. Okay, so let's proceed to the next example. So we have here, evaluate integral of 1 to 2, 0 to x, dy dx over x squared plus y squared. And again, we'll be integrating this first part here. Okay, so we'll leave this dx behind for later. So what we have is 0 to x dy over x squared plus y squared. And again, since we are integrating in terms of y, meaning to say x squared here is constant, right? And y here is our variable. So that looks like a squared plus u squared, which is equivalent to arctan. So we have 1 over a arctan of u over a, wherein our a here is x, our u here is y. Now, meaning to say, this one is equivalent to 1 over x arctan of u, which is y, over x, and we have the limits from 0 to x. Since we only integrate in terms of y, so the limits will only be substituted to the variable y. So we have 1 over x arctan of x over x minus 1 over x arctan of 0 over x. Now, if you would calculate this one, 1 over x arctan of 1, arctan of 1 is equivalent to pi over 4. And since we have 1 over x here, so that is, I'll just write it just to be clear, minus arctan of 0 is just basically 0. So meaning to say this whole term here will be 0. So our result for this integration is pi over 4x. And again, we are not yet done because we still have to integrate it again using the x this time. So we have integral of 1 to 2 of pi over 4x dx. Pi over 4 is constant. We can put that out. So we have pi over 4 from 1 to 2 dx over x. And as you can see, dx over x is just basically equivalent to ln, right? So we have ln of x, and that is from 1 to 2. So we have pi over 4 ln of 2, sorry, we have ln 2 minus ln 1. If you would calculate, ln 1 is just basically equivalent to 0. So meaning to say our final answer is pi over 4 ln 2. Again, I will not accept decimal answers. So it would be better to simplify your answer in fraction form or in this form, just not in decimal form. Okay? So this is now our final answer. Okay, next one. We have from 0 to 1, x to 2x minus x squared of x plus y dy dx. Okay, in this case, we'll isolate this one again. So we have from x to 2x minus x squared of x plus y dy. Since we are integrating in terms of y, we'll have x as constant. So since these are two terms, we can separate that. X is constant, so we can put that out. So we have 2x minus x squared dy plus integral of x to 2x minus x squared y dy. Okay, so I just separated these terms here. X is constant, so I put it out. Now integrating, we have integral of dy is y. Integral of y dy is y squared over 2. That is from x to 2x minus x squared. And then, we can already substitute that to our equation. So we have x times 2x minus x squared plus 2x minus x squared over 2 minus the lower limit, which is x times x plus x squared over 2. Okay, so we have x times 2x, we have 2x squared. X times negative x squared, we have negative x cubed. Plus the expansion of the binomial, 2x squared, that is 4x squared, minus 4x cubed, plus x to the fourth over 2. Minus this one, x squared. Negative times positive, this would become negative x squared over 2. Okay, so simplifying, we have let's write from the bigger exponent, we have x to the fourth over 2. We have negative x cubed minus this one, 4x cubed divided by 2, that is 2x cubed. So negative 1 minus 2, that is negative 3x cubed. We have 2 plus 2 x squared minus x squared minus 1 half x squared. So basically, this is equivalent to positive 5 halves x squared. So we are done with this. 2 plus 2 is 4, minus 1, 3. 3 minus 1 half is positive 5 halves, if I'm not mistaken. So that is 5 halves x squared. Then that's it. So we've already simplified our result for the first integration. Now, we have to integrate it again using 1 to 0 limits and the x. So we have 0 to 1 of x to the fourth over 2 minus 3x cubed plus 5 halves x squared. Then we have the dx. Okay, so x to the fourth dx is basically x to the fifth, and we have the 2 here, 2 times the exponent, so that is 10, minus 3x to the fourth over 4 plus 5x cubed over, we have 2 times the exponent, that is 6, so that is from 0 to 1. So substituting the limits, we have x to the fifth over 10 minus 3x to the fourth over 4 plus 5x cubed over 6, substituted by our upper limit, which is 1, will result to 11 over 60, minus, if you would substitute 0 here, is just basically 0. So meaning to say this is equivalent to 11 over 60. Okay, I hope this one is clear. We'll move on to the last example under double integration. So we have here 0 to x, y sine x dy is our inner integrand. So we'll be integrating that first. So we have from 0 to x, y sine x dy. And again, since we are integrating in terms of y, sine x is constant, so you can put that out. So we have 0 to x, y dy. Integral of y dy is just equivalent to y squared over 2. And we have the limits from 0 to x. So we have sine x of x squared over 2 minus 0, or basically is equivalent to x squared over 2 sine x. So this is now for the first integrand. Okay, So that is the result for the first integrand. Now, we have another integration which is from 0 to pi over 2 and the dx. So, we'll be using this result as our integrand. So, we have 0 to pi over 2 x squared over 2 sine x dx. 1/2 is constant. We can put that out. So what is left here is x squared sine x dx. So as you can see, they are both different. So we cannot integrate them directly. So we'll be using integration by parts here. So let u is equivalent to x squared. Du is equivalent to 2x dx. dv is equivalent to sine x dx. Meaning to say our v, integral of sine x is negative cos x plus c. So, we have 1/2 uv negative x squared cos x minus v. And since our v is negative, so this would become positive cos x 2x dx. Okay, so we have 1/2 negative x squared cos x plus 2 is constant, so you can put that out. We have the x cos x dx. So if you can observe, we cannot integrate this one yet because again, we still have the x here. So meaning to say we have to use integration by parts again. Let u is equal to x, du is equal to dx, dv is equal to cos x dx, v is equivalent to positive sine x plus c. Now rewriting, we have 1/2 negative x squared cos x plus 2 u and v sine x minus v, which is sine x. Then we have the du, which is dx. Okay, so we'll just continue it here. So what we have left here is we have 1/2 outside negative x squared cos x plus 2x sine x minus integral of sine x is just basically equivalent to negative, since this is negative sine x, integral of sine x is negative cos x, so this will become 2 cos x. And then we have the limit from 0 to pi over 2. So substituting, we have negative pi over 2 squared cos of pi over 2 plus 2 times pi over 2 sine pi over 2 plus 2 cos pi over 2 minus, okay, we'll just minus minus the lower limit. You can just write that. I think I cannot finish it until, so you just have to substitute it until 0. So for the upper limit, we have this is equivalent to negative pi. And then for the lower limit, we have 2. So basically, if we would calculate this, we have negative pi over 2, and then we have plus 1. So this is equivalent to positive pi. Then the lower limit would be positive 2. Okay, so I need to say our final answer is pi over 2 plus 1, or you can even have this as your final answer as well. Okay, so I hope the video discussion is clear, and we'll have triple integrals in the separate video. Thank you for listening.